So I'm just going to go through 3 examples. The first 2 are looking at simplifying ratios, and then the third one is going to be finding some unknown values within a ratio. So our first one, to write 27 to 45 in simplest form. Again, like we said, it's similar to when we try and reduce a fraction or simplify a fraction. We're looking for a common factor which we can divide each side by. So 27 and 45, I know what number is a factor of each. Yep, 9. So if I was to divide each side by 9, so you'd start off by saying 27 to 45, and then underneath you can just simplify by dividing each side by 9. So you should get 3 to 5 in brackets. You don't have to do this, but I'll just write it for this example. Divided by 9. So, like the guy from the Maths Antics video said, ratios are in a way very similar to a fraction, but just represented in a different way, hence why some of the processes that we do when we work with them are very similar. Alright, then example 2F2, we want to write 4.5 to 2.75 in simplest form. Now, what I'll do here is I want to try and get rid of these decimals. So to get rid of the decimals, what could I do? Is there something that I could multiply each side by? Yep, so if I multiply this side by 100 and this side by 100, we can move the decimal places. So this would start as 4.5 to 2.75. Then I multiply both sides by 100, so this is going to become 450 to 275. Now, if we, this might take a second to work out, but the highest common factor that we could divide both sides by is 25. So if I divide each side by 25, the ratio is 18 to 11. So that step, first we multiplied by 100, and then we divided by 25. Alright, and the reason why it was 25 is because it's the highest common factor. We could have divided it by other numbers, but it would just mean that it wouldn't have been in its simplest form. So you'd have to keep reducing it, similar to like when we had our fractions. Okay, now example 2F5 is a little more fun in my opinion. Maybe not in your opinion. But if I had 3 to 5 is equal to 21 to A. So 3 to 5 is equal to 21 to A. And we want to know what A is equal to. What is A? So again, all I'll do is I'll compare the left-hand side of the ratio to find what the multiplier is, and then the same multiplier will have to be used on the other side of the equation to determine A's value. So to go from 3 to 21, we multiply by 7. Therefore, to go from 5 to A, we also have to multiply by 7. Therefore, A will just be 35. So the way the textbook shows it, they showed that 3 to 21 they multiplied by 7, and therefore 5 to 35 they multiplied by 7, so A is equal to 35. So I'll show it the same way they did. They wrote 3 to 5 is equal to 21 to 35. They showed that the multiplier from here to here was times 7, and the multiplier from here to here was times 7. Therefore, A is equal to 35.